Let's continue to domain and range of composite function. As we know that for GF is performing F first and then G. So GF is you put F into the X of G. So that means the domain from the composite function GF is taken from F because we start with the F. So the domain of F will have the range of F that will be the domain of G. And as the result, we will have the range of G. So because this is the continuation function, I can draw this. So we start with F. So that means the domain of F will be used first, will be taken into the function F. And this will resulting the range of F. Now, we have to consider the range of F that the fit with the domain of G, because the range of F, the result of F will be continued by function G. So we have to make sure that the range of F will be suitable with the domain of G. And then it can be continued to range of G as range of GF. Yeah, this is very crucial, especially in the middle part, yeah, because you have to consider this is function G. You have to consider that the range of F will suitable with the domain of G. So we have to select the domain that it can be, we make sure that it can be continued until the end. Any restriction on the domain of F will have consequences for the number which become the domain of G and for the numbers that emerge in the range of G. Yeah, so this is for GF. How about FG? So that means we work the G first. So this is G, and then continued by F. So of course, the domain will be the domain of G, resulting the range of G, and we have to check whether the range of G suitable with the domain of F, and then continue to become the range of F, Gx. Let's see the example. Given that fx is 2x minus 3 and gx is square root of x. So we have to determine the domain of the respective function. The domain of f is a linear function, so the domain of f can be any number. So x is element real number. So it's from negative until positive. Therefore, the range of f is, we can put it x values to the function fx, and the range will be y are real numbers as well. Yeah, the same because this is linear function. Now, how about g? The domain of g is a square root. So we know that the square root cannot be negative, that the value inside the square root. So the domain of g is x should be greater than or equals to 0. So the range of g, when we put the 0 into the square root of x, so the y will be also greater than or equals to 0. Now we have the two domains and range for its function. Now, how do we determine the domain of fg and gf? So we start for the fg first, yeah? Fg means we work on g first. So this is g and then continued by f. So that means the domain will be the domain of g. So we take domain of g. The domain of g is, I write here, yeah, domain of g. So it's x greater than or equals to 0. Then it's continued to the function of g, and then we resulting the range of g is y greater than or equals to 0. So the range of g is y greater than or equals to 0. Now, this result will be continued by f. So we have to check the domain of f. The domain of f if x element real number. So I change the color here. So x, domain of x, f is x element real number. So the range of g will become the domain of f. So is the range of g fit with the domain of f? The g will produce positive number. F can accept all numbers. So that means all of the g's result can be fit into the f domain, yeah? The domain of f. So that means we can take the domain of g because all the g's result, the range of g, are fit in domain of f. So that means the domain of fgx will be x greater than, this is red because this is the g, yeah? So it's x greater than or equals to 0. So we can use this domain for fg. Now, since we take this, so x is greater than 0, we put into g, resulting y is greater than 0, and then it's continued by f. So y greater than 0, it's become x equals to 0. So x greater than or equals to 0. For the f here, I write it in blue. So you see that it will be different here. So this will be x greater than or equals to 0 for the domain of f. And the range of the f will be, if we put 0, yeah, it starts with 0, x, yeah. So we can put 0 here to the function f, and it will resulting negative 3. So that means the range of f is now y greater than or equals to negative 3. Because when x is increases here, yeah, x is increasing, the value of fx will be increased as well. So that means the minimum, the lowest point will be negative 3 and above. So the range of the fg will be this final range. Y is greater than or equals to negative 3. Yeah, so it changes from real number, all real number, into y greater than or equal to -3, because the domain changes from real number into 0, greater than or equal to 0. Yeah, so in this example, you see that we have to consider the middle part when the range of G fit with the domain of F. That's for Fg. Now, how about Gf? So that means we start with F. So this is F, and then continue with G. So the domain will be the domain of F. And then, so I make it blue again. So this is the domain of F. Put into the function fx will result in range of F. So the domain of F is x element real number. And the result, the range of F is y element real number. Yeah, here, the range of F. Now, this range will be the domain of G. So we see that the domain of G is x greater than or equals to 0. So in this case, we have some values of fx that cannot fit in the domain of G, because fx here, the blue one, can be -1, can be -2, because it's all real numbers. But the one that accepted by the function G is x greater than or equals to 0. So that means we have to ignore these results. That means we have to limit the domain of F. We have to find the domain of F that fit with the range of F, which is become the domain of G. So that means the minimum domain of G is x equals to 0. So the minimum range of F will be 0. So I have to write the fx should be greater than or equals to 0. Yeah, to follow this domain, the range of F should follow the range, the domain of G. So since the domain of G is x greater than 0, so that means the range of F should be also greater than 0. So the fx is 2x minus 3. I change blue again. So it's 2x minus 3 should be greater than or equals to 0. So that means 2x is greater than or equals to 3. So x is greater than or equals to 3 over 2. So x is greater than or equals to 3 over 2 will be the domain of f. So this will be x greater than or equals to 3 over 2. So if we put 3 over 2 here, it will result 0 here. And then it fit with the domain of G, so it can be continue to, we put it into the function G. So it will be equals to 0. Yes, square root of 0. So that means this will be the range of G. So the range of G here will be y greater than or equals to 0. So this is the domain of GF. This is the range of GF. Yeah, this is how you find the domain and the range of the composite function? You have to consider the area in the middle where the range of the first function should be fit, should be included in the domain of the second function. So you have to consider that. In the first example, we see that all of the domain of G, all the domain of G are fit in the domain of F. So we can take that's all numbers, x greater than or equals to 0. But in the second question, we see that only several numbers, several domain from F can be taken for to become the domain of G. Because at first, you see the blue one, yeah? You see the blue one? When X are element real number, all real numbers, the result will be Y everything, real numbers. But the problem, the G is only accepting X greater than 0. G are accepting positive numbers. So we cannot include the negative number from F. So we have to reject the negative number from F. That's why to check, to find the domain of F, so we have to set the range of F should be, this is the domain of G. Yeah. So the range of the of X should be the domain of G. So we know that the domain of F should be greater than or equals to 3 over 2. So if we have 3 over 2 here, we will have 0 as the range of F, and it fits with the domain of G, and so it can be continued by the function G to produce 0 in here. If we don't put 3 over 2, we put 1, for example, because we say that our X element real number, anything. If we put 1, I use black here. If I put 1 to the F, I put it to F, we know that Fx is x minus 3. So F1 will be equals to 2 minus 3 equals to negative 1. So the result here will be negative 1. So 1 become negative 1. And negative 1 is automatically rejected because it cannot be continued, because the domain of G should be greater than 0, positive. So the function cannot be continued. It stopped here because the result is negative 1. So that's why we have to limit the domain of F so the function can be continued. So only 3 and over 2 and above that can be continued to the end of the process. And that's for the domain and the range. This is the exercise. So you can try again as the practice. And we continue to the last part of this topic. This is inverse function. So inverse function is a function which undoes the work of the original function. So if we have a function f, if f is mapping from x into y, so the inverse function is mapping the y back into x. So this is the inverse function. So it's like if fx is mapping from x to y, the inverse function is asking the original value of the y. So what is the value of x for the values of y? So it's like a reverse process. So that's inverse function. So that's why in here, to do the inverse function, we have to switch the x and y. Because inverse is asking for x, not y. Function asking for y, from x to y. Inverse is asking for x. So this is the function, and this is the inverse, asking for what's the value of x that make this value of y. That's inverse function. Now, because the forward and the backward are functions, the forward and the inverse are functions, not relational. So that means this inverse function only works for one function. So the relation between the two variables x and y should be one function, because the forward function is a function. Here, the forward function is function, and the backward function is also a function. So it should be one function. And the relationship between the function and its inverse function is mirrored by the line y equals to x. It's being mirrored. You can see from the graph here. Yeah, it's always mirrored by y equals to x. So to find the inverse function, you have to make sure that the function is one function. Now, how about the domain and the range of inverse function? We know that, again, the function, forward function, is mapping x into y. So this is the domain, this is function, yeah, and this is the range. How about the inverse? So the inverse is this. So for the inverse function, we have, I put it blue, yeah. That means the domain of the inverse function will be y. So y will be the domain, and x will be the range, because inverse function is replacing y back to the x. So y will be the domain for the inverse, and x will be the range for the inverse function. So that's why in here, it's the domain and the range of the inverse functions are being switched. The domain of a function is the range of its inverse, and the range of the function is the domain of its inverse. So it's vice versa. Let's see the example. Find the inverse of this. So to do this, we have to switch between x and y. So this is y equals to 4x minus 3 over 2x plus 1. Now we switch x and y. So x equals to 4y minus 3 over 2y plus 1. Now we make y as a subject. So we collect y at one side, yeah, at on the left, yeah. So I can just do the cross multiply. So it's 2y x plus x equals to 4y minus 3. And then I collect the y. So 2yx minus 4y equals to minus x negative 3. So I factorize y. It's 2x minus 4 equals to negative x minus 3. So y equals to minus x negative 3 over 2x minus 4. Or I can just rewrite as x plus 3 over 4 minus 2x. So I switch the position of the denominator and make it positive in the numerator. Yeah. So that's the inverse function. Second, find the inverse of this. So again, this is y. Oh, we have to write the notation. So that means, so the f inverse x equals to x plus 3 over 4 minus 2x. Now continue to this. Y equals to 3 plus 2 over x minus 1. For x is not equals to 1, yeah, because it will be the vertical asymptote. So we replace x and y. So x equals to 3 plus 2 over y minus 1, and then we make y as a subject. So it's x minus 3 equals to 2 over y minus 1, and then I can just cross multiply. So it's become y minus 1 equals to 2 over x minus 3. So it's y equals to 1 plus 2 over x minus 3. So this will be f inverse x equals to 1 plus 2 over x minus 3. So this will be the inverse function. Now, if we see example number 2 and number 1, they are 1, 1 function. So that's why we can find the inverse. But if you see number 3, it is a quadratic. As you know, that quadratic function is not a 1, 1 function. So if you see, if we do the completing the square, yeah, so it will be x minus 5, yeah, x minus, this is minus 4, so it's become minus 2, so minus 2 squared. So this will be y equals to x minus 2 squared minus 9. So if we draw, the vertex will be 2 and negative 9, 2 and negative 9, and this will be U shape. And you see that this is not 1, 1 function. So we cannot find the inverse function for the many to one function. Yeah, quadratic is many to one function. But if we restrict the domain, we can change this many to one function into 1, 1 function. So if you see, the domain is limited only x greater than or equals to 2. So from the vertex, if you see, this is the line of symmetry, yeah? This is the vertex. Now I restrict the domain only for x greater than or equals to 2. So it will change the quadratic function from many to one function into 1, 1 function only. So I can just erase the x smaller than 2 like this. So it becomes 1, 1 function now. So if we restrict the domain, we will change the many one function into 1, 1 function. So now we can find the inverse function. Now, how do we find the inverse function of the quadratic? So the same thing, we have to switch x and y. And we have to switch x and y from the completing the square form. So this is another use of completing the square form. Yeah, we can find the inverse of the quadratic function. Yeah, you cannot do it from the original function. You have to change into the completing the square first. And then now we switch it, x equals to y minus 2 square minus 9. So just switch x and y. And then make y as the subject. So now y minus 2 square equals to x plus 9. So y minus 2, so we remove the square root, the square by root it. So square root x plus 9. And don't forget, it will be plus and minus. So y will be equals to 2 plus minus square root x plus 9. Now, and then which one that we have to take, the positive or negative? Now, since the domain are from x greater than or equals to 2, so we have to take the positive. So that means the inverse function will be 2 plus square root of x plus 9. So this will be the inverse of this quadratic function. Yeah, we take positive because it's greater than. But if we have x is smaller than or equals to 2, so which is the other part, so we have to take the negative minus x plus 9. Yeah, so you have to consider the domain. If it's greater than a number, it will be positive. If it's smaller than a number, it will be negative. So you have to choose. You cannot leave your answer in the plus minus because the function, the quadratic function, should has one inverse function because it's one function. Yeah, you have to consider this. And this is the exercise for you. See, if you see in the exercise number 4, the domain is smaller than. So that means you have to take the negative square root after that. Yeah. Okay, I think that's all for this topic. The next video will be used for the questions discussion. I think that's all. Thank you and bye.